In this video, we'll be discussing the quadratic equation y equals ax squared plus bx plus c, where a and b are both the same and c is equal to 0. Now let's start off where a and b are both 0. We get y equals 0, and the line across the x-axis, y is equal to 0. Now if we increase a and b by 1, we will get the equation y equals x squared plus x. Now the graph of this is a parabola that is opening upwards and crosses the x-axis at 2 points at 0 and -1. Now if we increase our a and b by 1 again, we will get the equation 2x squared plus 2x. And the graph of this is this orange parabola. Now there's a couple things we should notice about this graph compared to our other one. It is slightly more inside of it, which means it has a steeper slope, and it still opens upwards. Another thing that we notice is that the vertex is less than the vertex of this other equation. Now if we increase our a and b by 1 again, we will get that equation and a graph to look like this. As well as our graph before, this one is also steeper slope and inside the two that came before it. As a conjecture, we can say that the more as a and b increase, the steeper the slope of the parabolas we will get. Now let's look at what happens when a and b go negative. If we go negative by 1, we get negative x squared minus x. Now before we look at the parabola, we can look at the equation up here, x squared plus x, and notice that they are the same equation, except this one, the green one, is the negative of this one. If you multiply x squared minus x by -1, you get this equation. So if we look at the graph, we notice that is in a downward slope. And this is not really surprising, because if we're multiplying by -1, it reflects across our x-axis. So this parabola is a reflection of this parabola over the x-axis. If we decrease our a and b by 1 again, we will get the equation with 2's. Now we notice that these two are connected, and they're also reflections. So if we look at this graph and the orange one are again reflections of each other. They are steeper in slope than the ones that came before it, and their vertices are smaller and larger, respectively, than the a and b's that are 1 and -1. Now if we go one more down to -3 and look at that graph, we notice that it is also steeper in slope, and it is the reflection of our red graph. So we can make a conjecture as a and b become more negative, the parabolas will get smaller, the two sides will get closer together, and the slope will become more negative. Now if we look at the equation that we're using is where our a and b are the same, let's call them q, and we name that q, let's call it 5, and we create the equation y equals 5x squared plus 5. We can look at this number line and notice that as we increase q, the a and b increase as well. And if we graph it, we notice our 3 lines up with our 3 as well. So as we increase it, we notice that it is getting closer and closer together, and the slope is increasing. And that just further proves our conjecture as a and b increase, the slope of the graph increases as well. Now as we decrease it, we notice that the slope is becoming bigger, it's become wider and wider, and as we approach 0, we come across the inflection point, and we cross the x-axis into negative numbers. Now as we decrease our numbers more and more and more, the slope still becomes steeper, our vertices still becomes bigger than these since we're in the negatives and reflecting across the x-axis, and it becomes bigger and bigger and bigger. So as our numbers get bigger, our slope changes, and between as a is positive to a being negative, it changes how our parabolas and which way they face, whether they open upwards or open downwards.